Hey guys, welcome back to my channel. In this video, we'll be doing unit cells, crystal systems and cubic systems. So basically you have four types of unit cells. First is primitive or simple. Second is body centered. Third is face centered. And fourth is base centered. So first we'll understand ये कौन से unit cells हैं. Primitive and simple. Okay. These are the two names of the same kind. So now suppose ये है हमारा unit cell. Correct. ये सिस्टम बार बार रिपीट हो रहा है. फॉर एग्जाम्पल सो इन केस ऑफ प्रिमिटिव और सिंपल टाइप दीज कॉर्नर्स दैट यू सी, ये जो कोने हैं वहाँ पे हमारे एटम्स होंगे. ओके, सो 1 2 3 4 5 6 7 8. करेक्ट. 8 corners, 8 atoms. Abhi questions can be asked that how many atoms are present in one primitive or simple unit cell? How do we know that? If we pay close attention, ये अगर एक एटम है तो पहले तो ऐसे होगा. सो एक यूनिट सेल यहाँ 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 एंड यहाँ. बट इफ़ यू सी क्लोजली, ये जो हमारा एटम है इज ऑल्सो डिवाइडेड इन योर z axis, y axis in this case. So you have x axis, y axis and then z axis, right? तो ऐसे कटा, that means you cut it like this. ऐसे भी कटा, that means you cut it like this. So we have our x and y axis. No, x and z axis in this case. Now for y axis we'll have to cut it like this, right? So उस केस में ये जो चार आगे पार्ट्स बने हैं, सेम नंबर ऑफ पार्ट्स विल बी ऑन द बैक साइड. सो यू हैव 4 + 4. दैट मीन्स वन यूनिट सेल गेट्स 1/8 ऑफ द एटम. करेक्ट. एंड ऐसे कितने एटम है? 1 2 3 4 5 6 7 8. सो दैट्स 8 × 1/8. दैट इज 1 एटम. करेक्ट. ओके, नाउ यू हैव बॉडी सेंटर्ड. व्हाट इज देयर इन बॉडी सेंटर्ड? ये जो हमारा क्यूब है सिंपल वाला, उसके बीच में एक और एटम ऐड कर दो. सो हाउ डू यू हैव दैट? बेसिकली बॉडी सेंटर्ड में इफ दिस इज योर यूनिट सेल, what happens is, other than these 8 atoms, you will have one atom in the center as well. Okay, so how many atoms are there? These 1/8, that is one atom plus one whole atom in the center, so that's 2 atoms. Correct. Now we have the third type, which is face centered. So what does face centered look like? If this is your unit cell again, these 8 atoms are still constant. Okay, no matter which type of unit cell you go for, these 8 basic atoms are the same. That is, the 8 atoms with 1/8 part in your unit cell is constant. That means one atom तो पकड़ के चलना ही है. So now what is the unique part in your face centered unit cell? Every face has a half of the atom showing. मतलब एक एटम यहाँ होगा, एक एटम यहाँ होगा, एक यहाँ, एक पीछे, एक ऊपर और एक नीचे. सो उस केस में क्या होगा? जो हमारा एटम है, एक यूनिट सेल यहाँ होगा, एक यूनिट सेल यहाँ होगा. इट इज़ डिवाइडेड इनटू एग्जैक्टली 2 पार्ट्स. मतलब एक पार्ट में, एक यूनिट सेल में, देयर इज ओनली हाफ ऑफ एन एटम प्रेजेंट. एंड ऐसे कितने पार्ट है? 6, राइट? बिकॉज 6 फेसेस, एक फेस में हाफ एटम आ रहा है. सो दैट्स 1 2 3 4 बिहाइंड वाला एंड अप एंड डाउन 6. सो 6 × हाफ, दैट इज 3. करेक्ट. सो 1 + 3, दैट इज 4 atoms are present in your face centered unit cell. Now you have base centered. Just like our face centered, base centered में भी half of the atom is present. लेकिन what's the unique thing here? यहाँ पे अगर आपका unit cell ये है, for example, तो हमारा जो एटम्स होगा 1 2 3 4 5 6 7 एंड 8, करेक्ट. सो नाउ व्हाट्स द ट्विस्ट इन बेस सेंटर्ड इज दैट कोई भी दो ऑपोजिट फेसेस में, या तो अप एंड डाउन, या तो राइट एंड लेफ्ट, या तो फ्रंट एंड बैक, ऐसे दो ऑपोजिट फेसेस में यू विल बी एबल टू सी हाफ ऑफ योर एटम्स, राइट. फेस सेंटर में a half atom is present on every face. In your base centered, half atom is present on only 2 of the faces. तो कितने atoms हुए? एक atom considering 8 1/8, correct, plus half into 2. 2 क्यों? Because it's only there on 2 faces. Base centered में कोई भी 2 face होगा. Just remember this. So that is 1 again. So कितने हुए? 1 plus 1, 2 atoms. Okay. Now we have atoms यहाँ पे, we did unit cells. Now you have crystal systems. Okay. So in case of crystal systems, first of all you have you can say mathematical analysis has proven that only 14 different kinds of space lattices are possible. In other words, there are only 14 ways in which similar points can be arranged in a 3-dimensional order. So these 14 lattices which describe the crystal structure are called Bravais lattices. This is there in your textbook. Okay. So basically 7 crystal systems are there. Okay, and they are cubic, tetragonal, hexagonal. Then you have orthorhombic, rhombohedral, monoclinic and triclinic. In your year, you're only studying only one, which is cubic systems. So what are the 7 types of cubic system crystal systems? You have cubic, then you have tetragonal, then you have hexagonal. After hexagonal, you have orthorhombic, then you have rhombohedral, then you have monoclinic, and then triclinic. So basically all you need to know is कि ये shapes कैसे हैं. They are not going to ask you in detail about any of them. Now हमें इस year you're only studying cubic crystal systems. So cubic में what do you have? एक simple unit cell होगा, then you have body centered, then you have face centered. You don't have हर case का face centered, body centered, etc. only for cubic. Okay, so what do these shapes look like? Cubic is all these cases. Okay, cubes, all parts are equal, the height, the length and the breadth are all equal. Then you have orthorhombic. Orthorhombic में it is basically only one of them is different. So you can say height or suppose your length is same, your breadth will be different, or if your length and breadth are same, your height will be different. That's it. In tetragonal, what you are going to do is your same orthorhombic structure जो है, that is something like this, right? So what you call a cuboid is your orthorhombic structure. You will take this and you will tilt it a bit, so it becomes like this. This is not a 90 degrees, this angle changes. Then we have monoclinic, which is similar to this, but in this case all the lengths are different. Okay, in your monoclinic all the lengths are different. Then you have rhombohedral. Rhombohedral is like 3D structure of a rhombus. Okay, then you have triclinic, जिसमें all 3 angles are different. Okay, so you take this and change all 3 angles. None of them is 90 degrees, none of them are equal. All 3 angles are changing. So ये भी change हो रहा है, ये angle भी change हो रहा है, and ये angle भी change हो रहा है. Then you have hexagonal. Hexagonal में you have a hexagon, okay, somewhat like this, and you can elongate it. तो ये hexagon में if you add a height to it, it becomes your hexagonal. Okay, so this is your hexagonal. So what you are able to see is only everything other than this face. This is not clearly visible to you. Only this height and this face. Okay, since it's a 3D structure, what number of atoms can you have? 1 2 3 4 5 6. 1 2 3 4 5 6. And then depending on if it's a face center or a body center, it can be here and here, right, in the center of this thing. Those are the different types of structures you can have. Now, how exactly are you doing these? So if you know how you are placing your atoms, you can actually pretty much find all of these things. Okay, so now there is this packing structures called, there's a topic called packing structures in your book, wherein you suppose one layer of atoms is placed like this. Okay, if this is how one layer of your atoms is placed, your second layer can be placed in two ways. या तो इसके जस्ट नीचे आप दूसरा लेयर प्लेस करोगे, करेक्ट, या फिर अगर आपके पास ये एक लेयर है तो आप इसमें जो गैप आ रहा है यहाँ पे अपना दूसरा लेयर प्लेस करोगे, करेक्ट. सो ये इज वेरी लीनियंटली पैक्ड एंड दिस, इसमें आप जगह नहीं छोड़ रहे हो, जितना तो इतना क्लोजली पैक करो, करेक्ट. So this is your one dimension. So in one dimension you can arrange the spheres touching each other in a row. Okay, so if you just see this, this is your one dimensional close packing. Now you have close packing in two dimensions. So it forms a planar structure. मतलब ऐसे if you form a layer, एक sheet जैसा बनेगा, right? So उसमें there are two ways. या तो you keep it one under the other, that is square close packing, or you keep it like this. Okay. Now इसमें जब you're keeping it one under the other, you join the centers of your different spheres or atoms, you'll get a square, correct. Now when you pack it like this, okay, for example you're packing it like this, if you have to join the centers of your spheres, right, you'll join this, 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 this and this. What you're getting here is a hexagon, right? So you call this hexagonal close packing. When the atoms are kept one below the other, you have square close packing. And जब इन atoms को दोनों के बीच में गैप को कवर करते हुए रखा जाए, it's called hexagonal close packing. अभी 3 डायमेंशन में, 1 डायमेंशन हमने देखा रो बनता है, 2 डायमेंशन में you either have square close packing or hexagonal close packing. Now in 3 dimensions, you can stack them one over the other. Okay, so now for 3rd dimension, what we can do is you can stack these one over the other, right? So if you're stacking this, that is your square planar structure one over the other, then you can just get a cube, right? Now to understand how you're stacking them, you need to first understand how we are naming them. If I am naming this structure as A, correct, and I am keeping the same structure under it, this is A, तो इस पैकिंग को हम क्या बोलेंगे? A टाइप पैकिंग. ओके, अभी देखो, इफ आई एम नेमिंग दिस स्ट्रक्चर एज A और मैंने इस स्ट्रक्चर को थोड़ा शिफ्ट करके रखा, मीनिंग इसके नीचे ही नहीं आया, इसके बाजू में आया, राइट. नाउ सो आई विल बी कॉलिंग इट B. ये फिर से इसके नीचे आया है, करेक्ट, सो दिस विल बी A अगेन. अब अगर मैंने ये लेयर को फिर से रखा, दैट मीन्स इसके गैप्स में फिल किया, सो दिस विल अगेन बी B, राइट. तो दिस इज कॉल्ड योर AB टाइप पैकिंग. नाउ फॉर एग्जाम्पल what we'll do now is हम इस एक लेयर को हम समझेंगे A. Okay, so here if we have one layer of our square close packing and I'm calling this A, right? अगर मैंने इसके ऊपर यानी इसे सुपर इम्पोज करते हुए एक और लेयर रख दिया, मीनिंग इसके ऊपर के स्फीयर्स के साथ ये स्फीयर्स मैच होंगे, इसमें जो गैप्स है उसमें उसके गैप्स भी मैच होंगे, राइट, देन इट विल बी कॉल्ड योर A टाइप. ओके, सो अगर मेरा हाथ ऐसे है, आई कीप अनदर लेयर ओवर इट, दिस इज योर A टाइप, सुपर इम्पोज होना बेसिकली. मेरे थंब के साथ थंब जुड़ रहा है, इंडेक्स के साथ इंडेक्स, मिडिल फिंगर के साथ मिडिल फिंगर, राइट, रिंग फिंगर के साथ रिंग फिंगर एंड लिटिल फिंगर के साथ लिटिल फिंगर. एज इट इज रखा है, सुपर इम्पोज हुआ है, सो इट विल बी कॉल्ड योर A टाइप पैकिंग. बट इन केस व्हाट आई डू नाउ इज इसके गैप्स में रख दिया, मीनिंग यहाँ पे एक रखा, देन यहाँ पे एक रखा, देन यहाँ पे एक, यहाँ पे एक, यहाँ पे. दिस इज माई सेकेंड लेयर. ओके, एंड आई कीप वन हियर, वन हियर, वन हियर, वन हियर एंड वन हियर. मतलब इंस्टेड ऑफ कीपिंग इट लाइक दिस, व्हाट आई एम कीपिंग इट लाइक इज दिस गैप्स में फिट करूँ. सपोज दीज आर माई फिंगर्स, I'll keep this finger in the gap of the previous fingers, right? This will be called my layer B. So this becomes a B type, correct? So while I'm doing this, the first one जिसमें सुपर इम्पोज किया, एक के ऊपर एक रखा, एग्जैक्टली सुपर इम्पोज किया, जहाँ गैप है वहाँ इस लेयर में भी गैप है, इट्स कॉल्ड माई ए टाइप पैकिंग. इन केस आई कीप इट इन द प्रीवियस टाइप, दैट मीन्स इसके ऊपर ये रखा, it will be called my a B type packing. Now you can do the same in case of your hexagonal structures. Okay, suppose ये मेरा hexagonal structure है एक. Okay, this is my first layer. ओके, दिस इज माई ए. अगर मैंने इसके ऊपर इसी को रख दिया, सुपर इम्पोज किया, दैट इज माई ए टाइप पैकिंग. अगर मैंने इसके जो इसके वॉइड नल ये है वॉइड्स, ओके, व्हाट यू आर कॉलिंग दिस इज अ वॉइड. ये जो गैप है बीच में, यू आर कॉलिंग दिस वॉइड, राइट? यहाँ पे कुछ नहीं है. सो अगर मैंने इसके ऊपर नेक्स्ट लेयर रखा अपना, ओके, इस केस में आपको थोड़ा केयरफुल होना पड़ेगा बिकॉज यू कांट कवर एवरी void in only your second layer. This is a bit confusing for some people who are doing it for the first time. So अगर मैंने इसके just ऊपर रख दिया, then it will be called my B layer. अभी still कुछ voids बचेंगे, okay? उसके ऊपर भी अगर मैंने रख दिया, then it will be called my C layer. Okay? So now there are two ways you can do this. या तो ऐसे रखा, या फिर मैंने क्या किया, ये है, मैंने एक और लेयर रखा जिसमें एक इधर आता है, यानी इसके जॉइनिंग पे एक आता है, इसके जॉइनिंग पे एक आता है, इसके जॉइनिंग पे एक आता है. अभी भी ये एक गैप बचा रहेगा मेरे पास. उसके ऊपर मैंने एक और लेयर रख दिया, दैट विल बी माई सी लेयर. सो ये जो हमने 3 जॉइनिंग्स पे रखे, दैट इज माई बी लेयर. एंड ये जो मैंने बीच में बनाया एक, दैट विल बी माई सी लेयर. सो यू कैन इन दिस हेक्सागोनल स्ट्रक्चर यू कैन हैव ए बी. सो विल कॉल दिस ए बी ए. Then you have A, B, C. These are the 3 types of packings you can have. So in your closed packing, that is square closed packing, you can layer max to max 2 on them, correct? Because कोई void बचता नहीं है once you have placed your second layer. So it will be A, B, A or it will be A, right? In your hexagonal case, you can layer either A, or you can layer A B, or you can layer A B C, or you can layer A B C B A. Okay, so you can have A, or you can have A B A, or you can have A B C, then A B C again, or you can have A B C B A. Correct? So as you go on reading the chapter, you realize that all of these are just mentioned. You don't have to understand much about it, but this is what is mentioned in your book. Now these are just mentioned. In your cubic system though, you will be studying all of this in detail. So how are we going to do it? In your cubic system, you have just a simple cubic unit. You have body centered, face centered, right? So when I was explaining the different types, I had taken cubic systems into consideration. Okay, so basically the diagram shown in your book is very clarifying for that matter. This is the diagram in your textbook. So this is your simple cell. This is your face of the cube. This is also your face. This is also your side face. And there is nothing in between. ये जो this cube that you can, this atom that you can see is on the back side, this sphere, right? So it's just a simple cell. Body centered में you can see बीच में एक cell है, बीच में एक unit है. And in face centered, ये जो हमारे units हैं इनके बीच में, 4 units के बीच में भी एक है, that is your face centered, जो एक cube में सिर्फ half आ रहा है. Now you can see this is how I had shown. Simple cubic में only on the vertices, base cubic में कोई 2 faces पे, sorry base centered में, and then face centered में you have it in all sorts of faces. Now this is if you consider this to be a body center, एक है बीच में, right? Base center में क्या होगा, ये भी नहीं होंगे, correct? And you can only consider of any face, any two faces. So all these, if you hide these face centers, that is 1, 2, 3, 4, only these two are to be considered, right? That will be your base centered. Here's how it will be looking in a cube. So this is 1/8 of your atom, right? And there are 8 of them, so that's one atom. In base centered 1/8 of the atom है, and ये एक बीच में है body centered, right? So that's 1 plus 1. Then you have face centered. So 8 of 1/8, that is 1, and then half plus पीछे वाला half plus ये side वाला half plus top half and the bottom half. That's your 3 atoms. That's total 4 atoms in your face centered. Now we have to study the packaging efficiency. So what is packaging efficiency? Packaging efficiency का एक direct formula है. So your formula is packaging efficiency is equal to volume occupied by the particles, volume occupied by the particles in unit cell upon total volume of the unit cell. Okay, so how will we find out what our volume is occupied, right? So now you have to understand how we do this. In case of your simple cubics, right? अगर ये हम एक edge है हमारा, right? This is one edge. ये हमारा, for example, we are seeing one face. Okay, इधर हमारा जो यहाँ पे atoms हैं, this is half of your edge, right? So what happens is one atom takes up this much space, correct? And the other atom will take up this much space. What you see here is this edge of your cube is the same as 2 radii, correct? Let the edge of your cube be A, okay? And let this radius be R and let this radius be R. Since both the atoms are of the same element or the same type, the radii of the two atoms will be same. That means A is equal to 2R, correct? तो अभी मुझे अगर find out करना है कि in a simple cubic lattice, right? In my simple cubic unit cell, what is the volume occupied by my atoms? So that will be, since there is only one atom, right? And our volume will be 4/3 pi r cube, correct? Since my r is given here, I'll take this as 4/3 pi r cube. Now I need to find the total volume of my particle or this unit cell, right? What will that be? Since A is equal to 2R, volume of this unit cell was A cube. तो A cube होना चाहिए. But since it's 2R, so that's 2R cube, that is 8R cube. Now to find the packaging efficiency, it's not just this, okay? You'll be multiplying this by 100. Since it's efficiency, you'll be multiplying it by 100%. में answer आएगा, right? So what will we get? You will get first volume occupied by your unit cells, that is 4/3 pi r cube upon total volume of your unit cell, that is 8r cube into 100. R cube cut गया, right? 4 ones are 4 twos are, so that's going to be pi by 6 into 100. In place of pi, you can take 3.14, 3.142, 3.14159, right? It's upon you and what is given in your paper. If the unit is given in your paper, you have to take that. Else you can leave it in pi, you can leave it in, you can say let pi be equal to 3.14, right? You can take it that way. If it's not given in your paper, then it's best not to mention it. Leave it in the terms of pi. So now this is it. Well, in case of your body centered cube, right? What happens is your cube is here, for example, this is your cube what happens is this line, that is starting from the back corner, I'm taking till my front corner. Okay, I'm drawing a diagonal like this. The length of this diagonal will be root 3 r, right? So if you are applying Pythagoras theorem, first what you will do is take it for two sides and then take it for that side and this side. Going to be very easy because the angle will still be 90 degrees, right? So now if I'll be considering this line's length is root 3 r. Now what lies on this line? एक तो you have one whole body center, correct? दैट मीन्स ये एक बॉडी सेंटर्ड हमारा बॉडी सेंटर में हमारा एक एटम है, एक स्फीयर है. देन यहाँ पे हमारा एक एटम ऐसा है, करेक्ट, जो 1/8 है. देन यू हैव अनदर एटम ऐसा जो भी 1/8 है. सो हमारे पास रेडियस कितना है टोटल? यू हैव, सो दिस इज रूट 3a, सॉरी माय बैड, दिस इज रूट 3a बिकॉज ये a है, ये भी a है और ये भी a है, राइट? सो दिस लेंथ इज रूट 3a. आई बी कंसिडरिंग दिस r हियर, सो दैट्स r. इधर भी एक r है r एंड इधर 2r है, राइट, 2r. सो टोटल कितना है? 4r. तो हमारा a विल बी इक्वल टू 4 बाय रूट 3r और r विल बी इक्वल टू रूट 3 बाय 4a. Once you have got this, again you know the formula for volume of a sphere, you know the formula for volume of a square, you can easily find them out. Now we'll see how you find out the radius and side length ka relation in case of a face center, yeah. So now in case of a face center, you have to again refer to just one face. Why? Because this is enough. फेस सेंटर्ड में 3D में देखने की ज़रूरत ही नहीं है, राइट? इफ़ आई जस्ट कंसिडर दिस लेंथ दैट आई गेट इज रूट 2r. ओके, सिंस सॉरी रूट 2a, I have to find its relation with respect to r. So this is root 2a. What do we have? You have one face centered sphere or cell like this. You have one corner पे sphere like this and another corner पे sphere like this. So that's r, this is also r and this is 2r. So this is equal to 4r. So a is equal to 4 by root 2r, that is basically 2 root 2r, or your r will be equal to root 2 by 4a, which is equal to 1 by 2 root 2a. Okay, now again use any relation that you like, use any relation you find comfortable and find your volumes. So that's it. This is basically all the information you need. After packaging efficiency, you will mostly have numericals based on packaging efficiency, and you can be asked to find the number of particles in the metal, or you can be asked to find the number of unit cells in a metal, or you can be asked to find the density of the metal. Density is mass upon volume. Volume to you have found out, and mass you'll have to find using the number of particles, right? They'll give you the mass of one particle, the number of particles, or you'll be given itne unit cell hai, find the density, or you'll be said ki एक unit cell में, if this is the length of one unit cell, this is the size of one unit cell, find the density of this unit cell. So these are all the types of questions you might be asked, and mostly all of them are given in your examples, right? Nothing very difficult, nothing very hi-fi. And if you know the basic formula for volume and mass and density, you'll be good to go with all the questions from this section of the chapter. This is the ending of your chapter 1, right? So very easy, many topics, but once you understand the crux of it, very easy to solve. So that's it for the video. Don't forget to like, share, subscribe, comment down below, and tell me if you have any doubts or problems. So I'll be solving them in the comments for you. Thanks for watching.